Hello everyone, welcome to my YouTube channel Shilpa Data Insights.
In this video, we are going to see one more sorting technique, that is insertion sort. In the last video, we have seen how to do a selection sort and some searching algorithms like linear search and binary search. In this video, we will concentrate on insertion sort. We will focus on what is an insertion sort, then what is the working principle of insertion sort, how to code the insertion sort, and what is the time complexity of this particular sorting algorithm. So let's say I have an array A and I want to do an insertion sort on that array. So for insertion sort, the major technique is I have to pick up one element out of this particular list of array, and I need to find out the appropriate place in the sorted sublist and put it there. So you cannot put the particular element anywhere. You need to first find the appropriate place where you need to go ahead and place your element in that particular place. So for that, let's say I will consider this particular element as the sorted array and the rest of the element as unsorted array. Why I'm just picking one element here as the sorted array? The reason is if the array contains only one element, that element itself will be sorted. Okay, so therefore I'm considering the first element as the sorted array and the rest of it as unsorted array. So I have to check from this unsorted array what will be my next element that I need to put. So I will pick up the first element from my unsorted array and I will compare it with my sorted array and see if that particular element is in the sorted order or not. So here if you will see 2 is less than 5, right? So it should come before the 5, right? Then only it will become the sorted list. So in the first iteration, it will pick up the element 2 and put it before the number 5. Okay, so this will be our sorted list now, this particular option. Now this is still our unsorted list. So from this unsorted list, I will check where exactly I need to put that first element from my unsorted list into my sorted list. So if I will see 5 is less than 20, right? So it should come after the 5 itself. So our sorted list here in this case will be 2, 5, 20 and then 7 and 12. So in this we will have the sorted list as 2, 5 and 20 and this will be our unsorted list. Now I will pick up my next element, that is 7, and put it inside my sorted list after finding at which place I need to put in. So now 20 is greater than 7, right? So it should come before 20. I will check for 5. 5 is less than 7, right? So it should come in this particular place. After 2, 5, it should have this 7 and then 20 and then we have this 12. So in this particular list, this portion becomes our sorted sublist and this remains our unsorted sublist. So now I need to figure out where to put this 12. Now 20 is greater than 12, right? So we can put it here. But now I will see 7 is less than 12, right? So here basically after 2, 5, 7, I will put my 12 and then 20. So here what we are doing is we are finding where exactly I need to put my element to my sorted sublist. So I have to get a proper place in my sorted sublist to be put for my element that I need to put in, right? So in this case, I'm not swapping the element, but I am actually shifting the element. Let's try to understand with the help of an example. Let's say I have this array and the first element I'm treating it as a sorted array and the rest of the elements is an unsorted array. Now, why I'm treating this as a sorted array, the first element, because if the element is only one in the array, that means it is already a sorted array. So, our A of 0 is already a sorted array. Now, I will check whether A of 1 is either greater than A of 0 or less than A of 0. So, for that, let's first of all take a temporary location where I will be saving my A of 1, means the element that I want to compare and I want to go ahead and check whether it is sorted or not. I will store it in my temporary location. So this 4, I will be storing it in my temporary location. Now, I will compare whether this 4 is greater than 5 or less than 5. So what I will be doing is, I will check whether 5 is greater than 4 or not. 5 is greater than 4, right? So, I will be shifting exactly this particular 5 to my right of the place. I will be shifting this 5 to my 1 place. The rest remains 10, 1 and 6. And I have stored my 4 in my temporary location. So now this place is vacant. I will check whether I can place this 4 which is stored in our temporary location to this particular A of 0 or not. So there's elements left on the left side of it. So I can go ahead and put this letter 4 to my A of 0. So in my first iteration, this will be completed. Now, in my second iteration, this is my sorted sublist now, and this is my unsorted sublist. From my unsorted sublist, I need to pick up my first element and compare it with my rest of the elements to see where exactly I can put this first element from the unsorted array. Now, I will be saving this particular first element to my temp and I will compare whether 5 is greater than 10 or not. 5 is less than 10, right? So I don't need to go ahead and shift any letter to the right side. I just need to put it as it is. So it will be 4, 5, 10, 1 and 6. Now this particular is my sorted sublist and this is my unsorted sublist. From my unsorted sublist, I will pick up my first element, that is my temp is now 1, and I will check whether 10 is greater than 1, true. So I will shift my 10 to the right side. So here I have this particular place as vacant, right? So I will go ahead and shift this 10 to my right side. So my letters will be now here 10 and 6. Now I will check whether I can put that particular one in my this question mark place or not. So if you will see, 5 is greater than 1. So I have to again move this 5 to my right side. So it will be 4, question mark, 5, 10 and 6. Now again I will compare 4 with 1. So 4 is greater than 1. So I will again be shifting the 4 here. So 4, 5, 10 and 6. And I have this question mark. I don't have any elements left to compare. So I will be putting this letter 1 to my original place where it should be. So now this is my sorted sublist. This is my unsorted sublist. Now I need to compare the 6 digit. So I will be storing my 6 in my temporary location. Then I will compare whether 10 is greater than 6. True. So I will be moving right shifting my 10 here, and I will check for the rest of the elements as well whether 5 is greater than 6. That is false. So my right location where I need to put my letter 6 is 1, 4, 5, 6 and 10. So this becomes my sorted sublist now. So the main agenda is basically to store my digit in a temporary location and shift if in case that the digit from the sorted array is more than the unsorted temporary digit, then I have to shift it to the right. And this iteration will complete till it is there at the end. So let us write the code now. So what we did first is we stored our letter in our temporary location. So let's say I have a for loop and I will be starting the for loop for I in the range 1 to n. N is what? Is my length of the array. Okay. So it is actually length of A is my n. And why I am starting with 1 is because I am treating the unsorted array from the index 1. So for I in the range 1 to n, I will be going ahead and saving this index 1 to my temporary location, right? So that is in my temporary location, I will be saving my A of I. Then I will also check whether that element is greater than temp or not. That is whether this particular element is greater than temp or not. So for that, I will go ahead and create another variable called j. What will be j? J will be actually I minus 1 because here is my I. So j will be I minus 1. So I will be continuing the loop till we have j is greater than or equal to 0 and my A of j, that is this particular, is greater than temp. Till that only I will check, right? And then shift it to right. So how will I write that? I minus 1, right? J values I minus 1. Now I will create a while loop in which I will check whether j is greater than or equal to 0 and A of j is greater than temp. Then only the condition will satisfy and I'll shift my letter to the right. So A of j plus 1 is equal to A of j, means A of j is assigned with the value to the A of j plus 1. So whatever is on the right, that gets assigned to the left. Okay. Now, I will decrement this value j to j minus 1. Why I am doing it? So that the while loop gets decremented. Then I will go ahead and come out of this while loop, and inside the while loop, I will assign my temp value to my A of j plus 1. So this is my whole code by which I will be achieving the insertion sort. Now let's see what is basically our time complexity. If you would have seen in the best case scenario, I just need to go ahead and get this particular for loop. This is already in the ascending. Let's say it's already in the ascending order, right? Then I don't have to go ahead with the 2 loops. Let's say, for example, I have 1, 2, 3, and 4. In the first loop only, I will check and I will see whether it is greater no. Whether it is greater, no. Whether it's greater, no. And I'll just continue with the one loop. So our time complexity will be O of n. Guess what? What will be the worst case scenario? What will be the time complexity for our worst case scenario? In the worst case scenario, how it will exactly look like? It will have 4, 3, 2, and 1. So we have to compare each element and shift each element in order to go ahead and get it into our ascending order. So the time complexity for our worst case will be O of n square. So this is very important. Check it out again if you have a little bit of doubt how exactly it's implemented. Go through the video one more time. I'm quite sure you will be able to understand and how exactly it is implemented. I'll also go ahead and make the same video in Hindi, so stay tuned for that particular video. If you like this video, then click the like button and share it with your friends and subscribe to my channel.
Thank you so much for watching, and I wish you have a good day.